In this mini clip, we'll be discussing the properties of logarithms. While we answer this question together, you'll be solving the similar problem on your own using the same technique. We are asked to simplify this expression using properties of logarithms. The various properties that will be used throughout the solution are listed here on the left-hand side of your screen. So to begin, we want all three of our terms in our expression to be in the same form. We'll notice that this third term has a 2 in front of the logarithmic function, whereas these first two logarithmic functions do not have a number in front of them. So to begin, we're going to rewrite this third term here so that it will look like the first two. So first I'm just going to rewrite our expression right here. Okay, so this is the expression we want to simplify. Looking at this third term, we'll notice that it is in this form found in our logarithmic properties, where our r is a 2, our a is also 2, and our x variable is 3. So we can simplify this expression so that it'll look in this form. So we're going to leave the first two terms the way they are. So log base 2 of 5 minus log base 2 of 90 plus, now we're going to simplify this third term. It's going to be in this form. So we have log, and our a is our base, which in our case is 2. We're going to leave the number that's here, which is a 3. But this 2 will now become the exponent on this number here. So we will have 3 squared. We can further simplify this by writing 3 squared is equal to 9. So we will have the first two terms again will remain the same. Now we'll have plus log of base 2, and instead of 3 squared, we will now write 9. I want you to try this first step with the question that you were given. Here's the answer you should have got. Coming back to the question that we're working on together, we now need to further simplify this line here. We'll notice that we have one logarithmic function subtracted from the other, and then we're adding another logarithmic function. If you look at our properties, we'll notice that when we're subtracting logarithmic functions that have the same base, in this case the base is a, we can simplify this by writing log base a, and then we're going to have this number divided by the second number. So we're going to apply this property to our expression here. So we're going to subtract these two logarithmic functions. They have the same base, so we can apply this property. So we will have log of base 2. Now we take this number and it will become our numerator, 5, and this here will become our denominator, over 90. And then I'm going to write the rest of our expression. Plus log base 2 of 9. I'd now like you to try this step with the question you are given. Now we have two logarithmics being added to each other. Again, looking at our properties, when we have two logarithmic functions being added together that have the same base, this can be further simplified to be in this form. We're now going to apply this property to our expression since we also have the same base in our logarithmic functions. So this is going to equal to log of base 2. Now we're going to have this term, 5 over 90, times this number here, which is 9. So now we're going to simplify what's inside our brackets. We're going to be multiplying fractions. So 9 can be rewritten as 9 over 1. This is a fraction. And when multiplying fractions, we're going to simply multiply the numerators and multiply the denominators. So this will be log base 2. We'll have 5 times 9 gives you 45, all over 90 times 1, which is 90. I would now like you to try this step with the question you are given. Here's the answer you should have got. Now looking back at this question, we can simplify this fraction here. So we will have log base 2. So now we can reduce this fraction into simplest form. We'll notice 45 goes evenly into the numerator as well as into the denominator. So if we divide the top and bottom by 45, we will have 1 all over. 90 divided by 45 is 2. So log base 2 of 1 over 2. So we're still not done here because we'll notice that log 2 of 1 over 2 can be rewritten as, because it is in this form here, we can rewrite it so that we'll be subtracting two logarithmic functions. So we'll have log base 2, and then we take the numerator, this will be our first logarithmic function, of 1. Because we're dividing, we need to use this property, so now we're subtracting these two logarithmic functions, minus log base 2, and then we have our denominator here of 2. Now, we look here at our properties. The logarithmic function of 1 is always equal to 0. So this expression can be written as 0 minus, now log base 2 of 2. If we look at this property here, when we have the base is the same as this number here, it always equals 1. So this here is equal to 1. So 0 minus 1 is simply equal to negative 1. So this here is our simplified answer. I would now like you to try the last few steps with the question that you were given. You should find that your answer is also negative 1.